So look at here, determine the response of LTI system, linear time invariant system, whose x of n is equal to 1 to 0.5 and 1, and h of n is equal to 1 to 1 comma minus 1, right? So this is similar to the previous problem, but there is a change in this. There is one change, that is, they have also given the starting value, that is, the arrow mark is here in this question for h of n, and for x of n the starting sample is at here. The arrow mark is here. They are given like that, right, in this question, right? So we need to consider this. So x of n, let me write, x of n is equal to 1 comma 2 comma 0.5 comma 1, and h of n is equal to 1 comma 2 comma 1 comma minus 1, right? So this is my 0th sample, and in x of n, this is, 2 denotes my 0th sample, right? So it indicates that in h of n, this is n is equal to 0, and this is n is equal to minus 1. This is previous sample, and this one n is equal to 1, and this is n is equal to second sample, right? So there this is n is equal to 0 in x of n, and this is n is equal to 1, similarly, etc., right, up to 2, 3, right? So these are my sample values. Now I need to consider the value or the length of the given x of n and h of n, so that the formula for convolution is y of n is equal to x of n convolution h of n, right? Here the value of n1 is equal to the length of x of n. The length of x of n is equal to, there are 1, 2, 3, 4 samples, so n1 is equal to 4, and n2 is equal to 1, 2, 3, 4. So there are 4 samples, right? So the length of y of n can be written as n1 plus n2 minus 1, so which is equal to 4 plus 4 minus 1, which is equal to 8 minus 1, which is equal to 7. So my output y of n will consist of, or will have 7 samples, right? So in the answer, I need to get 7 samples, right? See, this is the length of y of n. Now let me solve using matrix method, that is, let me draw a graph or a table to find the value of y of n. So in column or in vertical, I will write x of n, and in horizontal or in row wise, I will write h of n values. So the value of h of n is 1, 2, 1, minus 1, and the value of x of n is 1, 2, 0.5, finally 1, right? So now after replacing x of n and h of n values in this table, I need to multiply the row into column or column into row values, right? Now let me take this first row to multiply with h of n, 1, 2, 1 and minus 1, right? So 1 into 1 I will get 1, next 1 into 2 I will get 2, 1 into 1 I will get 1, 1 into minus 1 I will get minus 1. Similarly, the second row values into h of n values, so 2 into 1, 2, similarly 2 into 2, 4, next 2 into 1, 2, next 2 into minus 1, minus 1, right? Sorry, 2 into minus 1, minus 2, right? Next 0.5 into 1, 0.5, next 0.5 into 2, I'll get 1. Next to 0.5 into 1, 0.5, 0.5. Next 0.5 into minus 1, minus 0.5. Right? Similarly, the fourth row into this h of n values samples. So 1 into 1, 1, 1 into 2, 2, 1 into 1, 1, 1 into minus 1, minus 1. Right? Now I have found out the convolution, I mean the multiplication of a x of n and h of n. Now I need to categorize the values into diagonal values, right? So this is my first diagonal and this is my second diagonal, this is my third diagonal, this is my fourth diagonal, and this is my fifth diagonal, and this is my sixth diagonal, right? So now I need to add the values of, or I need to add the diagonal values to get the value of y of n. So y of n is equal to, y of n is equal to, the first value is, here is only one diagonal value, 1. So I can write directly as 1 here, 1 comma 2. In this diagonal there are two values, two samples, so I need to add these two values. So 2 plus 2 I'll get 4. Next 0.5 in the next diagonal, 0.5 plus 0.5 plus 4 plus 1. So 4 plus 1 is 5, 4 plus 1 is 5. So 5 plus 0.5 I'll get 5.5, comma. Next in this diagonal, 1 plus 1 2, 2 plus 2 4, 4 minus 1 which is 3, comma. In another next diagonal, 2 plus 0.5 I'll get 2.5, 2.5 minus 2, 2.5 minus 2 I'll get 0.5. Next diagonal, 1 plus minus 0.5 I'll get, so 1 minus 0.5 I'll get plus 0.5, comma, the last diagonal there is only one value which is minus 1. So these are the samples of y of n. So totally there are 1, 2, 3, 4, 5, 6, 7. So there are 7 samples in y of n. So already I have found that the from x of n and h of n, the length of y of n is 7. So I have got 7 discrete samples in output y of n, right? So this is my answer. But I need to mention the starting sample of y of n. For that, in previous problem they have not mentioned any arrow mark in the given question. They have not given the starting sample value. So we have assumed that the first sample as the 0th sample. But in this question they are given x of n starting sample is first sample and h of n starting sample is second sample. So we need to manipulate this. That is, in x of n, this is my sample is 0th sample. So 0, I need to replace this with sample value 0, and in x of n it is n is equal to 0, means that it starts from minus 1. So the sample starts from minus 1 here, and they have given the second sample as 0. So but the actual sample, actual signal starts from minus 1. So 0 minus 1. So this is x of n, this is x of n, and this is h of n, right? So which is equal to 0 minus 1, which I'll get minus 1 as the answer. So this will resemble in this y of n, right? So y of n, I need to put arrow mark here. This is represents n is equal to 0. So this gives n is equal to 0, means that it has one more sample in minus 1, that is this n is equal to minus 1, right? Because I have got minus 1 as the answer. So the sample, output sample y of n starts from n is equal to minus 1, right? So my second sample is my 0th sample. So I need to put arrow mark in second sample, right? Because I always use it to represent the given signal or the output signal with the arrow mark to represent the 0th sample, right? So my 0th sample lies in second sample. So the previous sample is n is equal to minus 1. So I have draw an arrow mark in the second sample here, right? If they are not mentioned any arrow mark in x of n or h of n, then I can directly put arrow mark in this first sample to represent that it is my 0th sample, right? But from the given question, the arrow mark for x of 1 is at 0th sample, and for h of 1 is at n is equal to minus 1 or at n is equal to 0. There is one more sample in previous sample in h of n, that is minus 1. So I need to add this both. So 0 minus 1, I will get minus 1. So it represents that in my output the sample starts from minus 1 value, right? So I have represented n is equal to 0 at my second sample, right? So this is n is equal to, so this represent n is equal to 1, and this is n is equal to 2, and this is n is equal to 3, right, etc., right? So this is my answer.